Hello, I'm going to show you my DeepRacer car configuration for the model on the AWS side. My hyperparameter configuration is as follows. As you can see, the environment is the RE Invent 2018 wide, and we're using TensorFlow for the framework, and PPO for the training algorithm, which is as stated from Amazon, a state-of-the-art policy gradient algorithm, which uses two neural networks during training, a policy network and a value network. Um, Hyperparameter values, we have the gradient descent batch, which is the what promotes more stable and smooth updates to the neural network weights of the car. A bigger value would affect training time, make it longer. So I picked something like one up from the default value of 64. The entropy is what adds randomness to the model, which encourages the car to explore more grounds, like the off track or anything to check for more points. I have a smaller value. It's from 0 to 1. I have a smaller value to discourage that. Like it would stick to the path that works best when it does find it. The discount factor is what how related steps are. Um, a discount factor of 0 means that the current state is independent from the future steps, whereas the discount factor of 1 means that the contributions from all the future steps are included. So a 0.999 means that the reward is gonna be like this discount factor is gonna be based on at least 1,000 steps from the current one. The last type, the mean squared error, is the one that fits best with this model because I'm trying to achieve conversions. A good training algorithm should make incremental changes to the vehicle strategy so that it gradually transitions from taking random actions to taking strategy actions to increase rewards. So the other one is more about the when you're not concerned about convergence. So uh, the learning rate is what controls how much gradient descent or ascent updates contributes to the network weights. A higher value means a faster training, but it could also increase the time it would take for the car to reach convergence. The number of experience between episodes is the size of the experience buffer used to draw training data from learning policy network weights. A recommended value here, like recommended values here are 10, 20, and 40. I picked the middle one. The number of epochs is the number of passes through the training data to update the neural network weights during the gradient descent. When it's with a small number, we can use a smaller number of epochs, but it could also affect the training time. So that's why I picked 8. The default one is 10. It's yeah, and the speed is from zero point 0.5 to 1. Um, this is the track we are using, and my strategy is to drive the closest to the center, and then drive as fast as possible when it's possible. Um, so like the reward function checks the middle line, and also the at line 22 you can see that I also check the speed. We were using the time trial for this one and PPO. Um, and this is what my first model did. It declined because I had an error when during the training it was not finding the model for the car, which is kind of not a good thing. But it was working a little better. So I'm cloning and also increasing to get a better evaluation. So here I use 5 trials, which is it's gonna go 5 times. This was the video. It's kind of slower than the scores on the right side. My best thing, the best like times were the second and third trial for this one. So right now I'm trying to stay closest to the line and also drive fast. But I probably need more cloning and increasing the performance by training more, and maybe use SageMaker to help with the error for the reinforcement model not being found while training, and also try put it in the car and see how it goes, and of course more training. I've also like the model is automatically submitted to the competitions on DeepRacer site, and I'm currently 157 over 422 participant, and this is the top racer. So I'm hoping to be like to get a higher rank on that.